Hello folks, welcome back to the HS Tech Channel. In this video I'm going to attempt to do my best to show you how to do amplitude modulation, frequency modulation, stereo, and also not stereo, AM and also FM. Yes, we are looking at the infamous stereo AM system, and of course stereo FM. Now I'm going to say this is going to require you to know a little bit about SDRs. Now I have here two SDR programs. I have SDRuno, which is a little bit clunky to use because the user interface is a little crusty. So let's start closing some windows so we can have at least a little bit of room here, and we'll shrink up this scheduler. You're probably wondering, how do you get any of this to show up without actually having an RSP if you don't actually have an RSP device? Just set opt, and then over here, well, if you do have it plugged up, you'll be able to set the input to a WAV file. But in this case, if you just start up, it'll say, do you want to start on a WAV file? And you can say yes, and then boom, we'll be good to go. So the first thing that you'll need to do is make sure that you have a reasonably new version of Audacity. I'm using one called SodiraSDR. It's kind of a silly name, but it gets the job done. It's basically an open source version that's a little bit easier to compile. Now I have here a test song, some good 80s music, so we'll go ahead and slam that in here. And note the sample rate. This right here is just a 48 kilohertz wave. That's not going to cut it. We're going to need a lot more sample rates. So go ahead and drive it up to 384K. Now from here, you need to go to tracks, resample, and you're going to need to resample your audio track and get it up really high. Now we're going to start with AM, so of course AM is pretty easy to do, so go ahead and go to tracks, mix, and mix stereo down to mono. This right here will produce our audio baseband signal. Now generate a tone. We're going to generate a 50 kilohertz tone at an amplitude of 0.25, and if you do Control A and then just click out, it'll automatically size how much length you need here. Now go ahead and go here and make a stereo track. Now go to Tools and go to Nyquist Prompt. And I have here two presets, one for AM and one for FM. So go ahead and load this AM one. What this is doing is it's doing multiplication. An actual amplitude modulation circuit, it's basically a multiplier. So go ahead and do multiplication here. And you're going to see that we end up with a stereo track that we don't really necessarily need. We only need one of these. This right here is our double sideband suppressed carrier signal. If we go into spectrogram and we set the spectrogram to cap out at 1/2 of our sample rate, and we zoom in and look really carefully, you can see there isn't really a carrier at all. That's because this is at 100% modulation with no carrier reinsertion. So come down here and go and generate that exact same tone again, and this will actually be our reinserted carrier. So we'll go ahead and get this back to just the regular, well, at least as best as I can, and we'll get this back on waveform. Now, select these two tracks and go to Tracks, Mix and Render to a new track. Now, this right here is our actual double sideband with carrier AM signal. Zoom in and note the modulation. If you've ever looked at AM on an oscilloscope, you'll know that this is basically it. And it looks exactly like what you'd expect. And now this is good because we have 100% modulation on the strong peaks. So go ahead and select this, go to File, Export, Export as a wave. And we're going to call this AM Test 1. And, oops, I should have soloed that beforehand because we don't want all that to clobber together. Go ahead and export that. And then come on over here to SDRuno, go to your scheduler window and click on File. Click this here and then pause. So make sure that you have 100% volume here. Now, click on AM. Make sure you have 20 kilohertz of bandwidth will do, and then when you click play, sorry, that is extremely loud. You'll be able to also enlarge the bandwidth, if that would stop popping over like that, to be slightly larger. Now I know there's two, that's because this is an SDR. Everything comes in twos with an SDR. This right here is the center axis right here. This is real frequency, this is quadrature. I guess you could say negative frequency. And there you go, it's just regular old double sideband AM. And you can see the limit right here is about this far out. It's about 20 kilohertz or so. So we'll go ahead and quiet that so we can stay focused, and we'll stop this. Make sure you click stop enough times and it will unlock the file. Now, come back over here to Audacity, and now we're going to do FM. So get rid of these, and this is actually like trivially easy to do. Actually, come back here before you modulate. There we go. And select that and go to Nyquist again and use this preset here. Now this one is a little bit more, I guess you could say, automatic. This right here is the carrier frequency, and this is the modulation depth. So this is the actual RF frequency that you're going to get, which is 96 kilohertz. Pretty low in terms of RF, but it's still nonetheless something. And this right here is the modulation depth. Of course, this is 1/3. If you set the modulation depth to like 1/50th, you'll end up with a pretty narrow signal, but be careful, it may be kind of distorted. And then we'll just use the FM oscillation function here, and we'll go ahead and apply that, and then you're going to say, boom, we get 100% modulate, or 100% duty cycle modulated signal. If we zoom in, you'll be able to see some of the deviation in frequency there, although it is kind of hard to see, simply because we are looking at something that also has not the best rendition of really tight waveforms. And if, of course, we spectrogram it, well, there's nothing to see here, so change the spectrogram settings and plug in your sampling or your Nyquist frequency, which of course is half of your sample rate, and then boom, there you go. You can actually see the modulation. Now, if we do an analyze and a plot spectrum of this, you'll see here we are. You may want to set this to linear frequency, by the way, and there you go. This is exactly what you expect seeing a spectrum analyzer of an FM signal. Now, the bandwidth is rather tight, and that's simply because of Carson's bandwidth rule. We're not pumping in a stereo signal yet, so the bandwidth is relatively tight and it's not taking a lot. So we'll go ahead and export this as wave. Oops, all audio is muted. Yeah, I know. Alright, export as wave, and we'll call this FM test mono. Alright. Come back into SDRuno here, and we're going to stop and reopen this right here. Now we'll crank up the volume. You're going to hear some horrible crunch. And then we're going to go ahead and go into FM. We'll go 120 kilohertz should be good. And of course we have our two signals. And because it's mono, we can tighten up the filter a good bit. And then we can hear the actual audio. So as you can hear, the audio quality is perfect. It's because we have absolutely no noise in the system whatsoever. If you want to add some noise, you can actually do that as well. We can generate noise and do a amplitude of about 0.1, and white noise would be alright. Of course, this is a broadband noise, and then if we drag down the noise to about 20 dB or so, we can export this as a wave, FM test mono with noise. And of course it's going to do a mix down. We definitely want a mix down for this to work. Come on over to SDRuno, open it up, and then crank up the volume so you can hear. You can also see the file here. It's pretty good, and the reason it sounds pretty good is because it's a mono signal. With FM, the higher in frequency you go in the audio spectrum, the more susceptible the signal is to noise. But we're not here to talk about theory all day, we're here to talk about practice. So go back here to your original audio signal. Let's do stereo. Now FM stereo works by hiding the stereo difference signal away in the audio passband. So we're going to do exactly that. So duplicate your signal here, because we need to mix this one down to mono. This is going to be our left plus right. Now we need to make a left minus right. And if you're familiar with FM stereo works, or I guess you could say how it works, you'll know exactly what I'm doing here. Split this to mono, and then go to effect, and then invert this. Select both of these, mix them to a new track. Alright. This here is left plus right. This is left minus right. If we listen to this, it's going to sound kind of weird. Obviously, it's kind of odd. Of course, if we listen to the baseband, or what will be the baseband, it sounds fine. Okay, so what we have to do is we actually have to do some amplitude modulation, because the FM stereo difference signal is actually amplitude modulated, but it's a double sideband suppressed carrier. Fortunately, we already remember how to do that, but we need to generate a tone. This time it's at 38 kilohertz. This is the carrier for this. Alright, make a stereo track. Tools, Nyquist prompt, AM. Alright, there we go. Now we don't need a carrier, so we don't need to reinsert that at all. You're probably going to want to amplify this a fair bit. And then of course if you want to see that change, you can mix and render to a new track. But we need to insert a carrier, and it's the 19 kilohertz stereo pilot tone. So go over here to generate and generate a tone and generate 19 kilohertz. Now in practice, an FM receiver needs this to be phase locked to this. And by default, because it'll start at far left, they're phase locked. This alerts the receiver that this is actually a stereo signal. Now, if we analyze and we plot the spectrum of this, and we go on linear frequency, you can see that we have a bit of an issue. And I did this on purpose to show you why you need to do this. It's kind of hard to see, but if I drag this out, you can see it a lot better. You can see here's our audio baseband signal. This right here is our stereo pilot tone. And then this right here, this is the upper sideband, this is the lower sideband of our stereo difference signal. You see the issue? It's all sort of kind of merging together. We don't want this. So let's fix it. Close this and back up a little bit. And go back before you actually did your amplitude modulation. And what we're going to do is we're going to apply a filter curve. So we're going to affect filter curve EQ, go flatten this out, and we don't want anything past about 15 kilohertz should be good. And you're going to want to apply it multiple times just to make sure that it's absolutely 60 dB of isolation and loss. And also do it for your stereo difference signal too. And you do not want any sort of, I guess you could say, spectral collision occurring on that stereo pilot tone. Also, I just realized this is actually, I think it's modulated. Hang on. Let's spectrogram it. Yep, okay, that's baseband. Okay, we'll go back on waveform and make sure this is what I think it is. Yep, this is our stereo pilot, or not our pilot tone, this is our carrier. So we'll make a stereo track out of that, and then we'll go ahead and modulate that. Alright. Split to mono, amplify it a little bit so that it has decent power in the signal. Mix and render to a new track, get rid of the quiet one, generate our stereo pilot tone. Now we'll do a spectral analysis of it. Now you can see we have a clear notch out. You can see we have a isolated tone, if you will. So it's no longer going to be fought by portions of really high audio frequency crashing into that, which can, in practice, for a real receiver, actually cause issues. Okay, so now we're going to adjust the levels a little bit. We don't want to overdrive anything. Drop everything by about 3 dB. Mix that to a new track. So this right here is our combined audio baseband. If we spectrogram it and we set the maximum frequency to be 54 kilohertz, you'll be able to see baseband signal down at the bottom, pilot tone, double sideband, suppressed carrier, stereo signal. Now go back to Nyquist prompt and switch this over to FM. Again, this is what we're doing, same parameters as before. And if we set the spectrogram's limit to the sampling frequency, or the half the sampling frequency, you can see we have now a much wider signal. That's because an FM stereo signal obviously has much higher frequency components. I mean, we're going up to 54 kilohertz with this. So obviously it makes sense that we have a much wider deviation signal because of the bandwidth rule. Alright, so solo that, and now we're going to export this also as a wave, but we're going to say this is FM stereo. Alright, and what you're going to hear is probably going to blow you away. If it doesn't work, we need to increase our loudness of our carrier here, because SDRuno seems to like a loud FM pilot tone here. So FM stereo, aha, you see it's not tripping it. We didn't go loud enough. But you can see that nonetheless, it is at least being decoded correctly here. So let's drive up the amplitude of that a tiny bit. We'll keep it at 0 dB. And of course you can use the trick there. Make some room to new track. And modulate. And export. Oh, ooh. Ooh, that is going to cause massive distortion if that happens. Alright. There we go. And if you listen, that is in fact in stereo. It definitely sounds like it's in stereo to me, and I'm just using some headphones here. So, there you go. Now, for the final boss, AM stereo. Now, the problem with AM stereo is it's kind of difficult to wrap your head around what's going on. But what it is it's quadrature modulation. Now, you're probably wondering, okay, what in the world is that? It's honestly not that bad. Go back here so that you have your left plus right and your left minus right. Remember how we got left minus right? We got it from invert left, add to right. Now, this is where it gets a little difficult. So we're going to generate our tone, and we're going to generate a 50 kilohertz carrier. We're going to go ahead and modulate our signal here, and this is going to seem like magic, but trust me, it works. Nyquist prompt there with our AM. Regenerate our carrier frequency. Split that to mono. Come back up here and sum these two together to produce our standard signal. Okay, at this point we have an AM signal, and then we have this not so useful stereo difference signal. Okay, so we need to apply a phase shift, and it's actually not that difficult to do. Generate another 50 kilohertz tone, duplicate it, and zoom in, like all the way. And what you need to do is you need to align this the best you can, such that at the peak of one of these, or like when it's zero crossing, the other one is just now full crossing, okay? You see that there? This is how I know it's been phase shifted by 90 degrees. Get rid of this one because we don't actually need it. This right here will now be amplitude modulated. But because this right here produces a double sideband suppressed carrier signal, let's make double zeros to offset, we don't actually need to re-inject the carrier. Okay, so what in the world did we just do? Well, essentially we have a delayed signal. We have a signal that is 90 degrees out of phase. Okay, so sum these together, and I know this is going to seem like magic, but we now have an AM stereo signal. Let's do a spectral analysis of it really quickly. Actually, we'll just do plot spectrum. It looks like normal AM. Also, the percent modulation of this is horrible. This is not very loud. You may want to increase your audio drive there. But we're going to export this as AM stereo. I know it seems impossible, but trust me, it should, unless I'm like gravely mistaken, work. Now, SodiraSDR is actually capable of doing AM stereo. Okay, I know this is like the most complicated user interface ever, so let me like minimize some programs here so we can only see, oh my goodness, minimize please. Okay, now we can only see this here, so we will actually survive. Okay, it's a lot of buttons, but here's your tuning. You probably want to open all these. Here's your file manager. So, oh my goodness, open file, AM stereo. Okay. Yeah, we'll do right channel. Yeah, 16-bit PCM, boom, 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 looks good. We're going to do AM envelope, but we're also going to try stereo. So go ahead and, actually we're going to dial that back a little bit. Click start. I know that sounds horrible. Alright, come over here. You can see what we're looking at over here. Let's crank that up so we can hear it. Now, oh my goodness, I forgot to do something. Oops. Okay, I forgot to generate the stereo pilot tone. Aw, man. Okay, we gotta go all the way back to the start. Okay. Let's try that again. Alright. let's make sure we only have baseband signals in here. Okay, we only have baseband signals. Okay, let's try that again. Generate a tone and generate a 0.2 amplitude 25 hertz tone. Oh my goodness, this is so bad. Okay, mix these together. Mix them into your new track. Okay, we now have our pilot tone laden signal. You can actually hear this, by the way. You can actually hear that 25 hertz pilot tone if you have like a really good headphones or like booming speakers. Yeah, you'll be able to hear it. Alright, let's try that again. Okay, generate a tone. Remember, 50 kilocycles, 0.25 amplitude. Oh man, this is such a bad example. Alright, mix them into a new track. Alright, get rid of these. Actually, we'll keep this because we're going to need it again. Of course, we need two of them so we can do the phase shift trick. There we go. Actually, something does not quite look right here. Okay, I think I just messed something up. I was not paying attention. Okay, yeah, so there we go. This is amplitude modulated because we can analyze plot spectrum. You can... Oh my goodness. Okay, I am like bunging this up so badly. Okay, let me actually like pay attention. Okay, so this right here has our 25 hertz pilot tone. We need to generate our carrier frequency. Of course, we need to have it aligned. It's no good if it's not. Actually, just to be double sure and make sure that it's not going to have some weird phase shift applied to it. There we go. Okay, yeah, this is probably going to need to be retouched a little bit. Okay, AM that. Okay, there we go. Now we'll generate our tone. Split this to mono. Make our AM. Okay, and then here's our stereo difference signal, because if we plot the spectrum now, you can see this useless baseband over here. We need to get it on there. So, again, generate two tones. Now remember the trick. Come back over here, line it up. That looks good there. Okay. Get rid of this since we no longer need it. Make a stereo track. Tools, modulate. Split to mono. Get rid of the second one because there's a tiny bit of delay to it. Select both of these. Mix them into a new track. Export. Oh, caps lock was on. Okay, let's try this for real. Okay, now put it in stereo. There you go. I can't say it very often, but I am dang impressed I was able to wing that on the fly like that. So it is synced. It is detecting the pilot tone. We don't have AMSS. That's way too difficult to generate. That requires like GNUradio. But there you go. That is in fact in stereo, as you can hear. Now, just for fun, we'll do FM as well, so you can at least get the gist of doing it on here. Demodulation type FM. We'll go ahead and start that. It's a little bit overdriving, I think. Of course, this is a lot wider of a signal, so we'll need to scale back the width of that bitmap. Turn on stereo. I know it definitely sounds like a stereo to me. Uncheck the audio bandwidth filter. Cap it at 15 kilohertz. Do not do 20 kilohertz or you're going to hear that nasty stereo pilot tone. If you're young like me, you can hear it and it will sear your ears out. Can you hear me calling? Oh, yeah, I can actually hear that. That's why. Because that's really loud. Now, this thing won't actually tell you that it hears the pilot tone for some reason, but it is working. But I think that will actually do it. I apologize for bunging it up a little bit, but there you go. That's how you do AM mono, FM mono, AM stereo, and FM stereo. I think it's pretty simple to do. So go forth and prosper and have fun.